Hello, and welcome to another video in this series looking at how to achieve structural steel design using AI and retrieval augmented generation. In this video, I will demonstrate my steel design agent at work directing Claude Opus 4.8 to design a FEMA 4-story SMF steel building, PG2ELF SDCD Max. The era of autonomous single-prompt structural steel design is here. This is how the steel design agent takes a building from brief to delivery in 8 steps. It starts by scoping the design, geometry, lateral system, gravity loads, and the seismic and wind site parameters. Then it composes the configuration and builds the model sections, joint fixity, and column bases. Next, the OpenSees pipeline runs the loads, the full LRFD combination set, and a second-order analysis, then envelopes the demands. From those, it derives each member's capacity and demand-to-capacity ratio, citing every clause. Wherever a check fails, it iterates, resize, rerun, rederive until everything passes. It then applies seismic detailing, runs final QA, and produces the report, closing with an optional pass to optimize member sizes. Every decision this agent makes is grounded, not guessed. The steel design agent directs Claude to back each design choice and calculation with evidence pulled from vector databases. There are two. The first holds the AISC specifications, 360, 358, and 341, covering general steel design, pre-qualified connections, and seismic provisions. The second holds OpenSees knowledge, 40 sample buildings, 20 verified buildings, and the complete OpenSees and OpenSees PI documentation. As it works, Claude searches these databases for three things: the relevant code clauses, real model input files to build from, and the documentation for using the tools correctly. The payoff: every result is traceable to a source. This is the complete structural design report for Frame 1, a 4-story steel office building, modeled as a FEMA P695 perimeter special moment frame archetype. 13 chapters, front to back. Chapter 1 sets the design basis. The codes are the 2022 editions of ASCE 7, AISC 360, and AISC 341, with Risk Category 2, Seismic Design Category D, and a Response Factor R of 8. The building is 140 by 100 feet, 7 by 5 bays at 20 feet, 4 stories, 54 feet tall, all A992 steel. The opening figures show the analysis model, the column grid, and the member orientations. Chapter 2 lays out the lateral system and load path. Perimeter moment frames carry the lateral load, and the deformed shape confirms a continuous path down to the foundations. It distributes the story forces to each frame, classifies the floor diaphragm, and screens for plan and vertical irregularities. Chapter 3 covers the loads, gravity, wind, and seismic. It works through the seismic response coefficient and the modal periods and arrives at a design base shear. Chapter 4 assembles the full strength design load combination set, 18 cases including the seismic directional, accidental torsion, and overstrength combinations. Chapter 5 checks the analysis itself. Every modeling assumption, equilibrium in all 3 axes, the first 3 mode shapes with a fundamental period just over 1 second, and the governing shear and moment diagrams for each frame. Chapter 6 is the member design to AISC 360. The beams and columns each get a governing limit state, a capacity, and a demand-to-capacity ratio, all at or below 1. The members are color-coded by size, and the connection demands are tabulated. Chapter 7 and 8 cover stability and serviceability. Story drift peaks comfortably under the 2% limit. Chapters 9 and 10 handle the seismic detailing and the connections, the strong column weak beam check, the reduced beam section moment connections, the splices, and the column bases. Chapters 11 through 13 close out the foundations, the documentation, and the quality assurance scorecard, where every check passes and the numerical self-consistency check is clean. And it ends with the appendices, the fully referenced AISC calculations for every member, the member forces under all 18 load cases, and a complete log of every step that built the report.